Hi, my name is Daryl Osborne, and I'll be diving into the AWS storage world and walk through the key benefits of running data science and analytics workloads on the AWS cloud. When you run data science and analytics workloads on AWS, you gain faster access to tools and updated environments, faster access with collaboration and centralization, and faster innovation, as well as more freedom to innovate because you spend less time worrying about infrastructure. In today's Tech Talk, I'll give you an overview of file storage for data science, why it's beneficial to run your data science projects on AWS, how to choose the right platform, the value of AWS managed storage services, and I'll walk through a quick demo of Amazon EFS. At the end, I'll wrap up showing a few links and references on how you can get started with your data migration journey. More and more customers are building and deploying applications using containers and moving their analytics and underlying storage to the cloud. Why? Well, because building containerized applications at scale requires data storage solutions that are globally accessible, highly available, and allow high-performance data processing. By moving into the cloud, organizations are increasing efficiency and reducing costs, but also increasing innovation. Develop applications faster and better with agility. With containerization, it allows you to develop teams to move fast, deploy software efficiently, and operate at an unprecedented scale. Containerization also provides a clean demarcation of responsibilities, allowing developers to focus on their application logic and allowing IT operators to focus on deployment and management without concern for the nature of the application being deployed. In terms of collaboration and centralization, you also get access to data faster. When developing new apps for the cloud, customers have to remember that building for a very different characteristics than before. That one-size-fits-all approach of legacy infrastructure will not really enable the type of scale that's required for modern applications. Without modernizing your infrastructure to align with new development and deployment models, you will reach bottlenecks, limitations, and incur higher costs. And in terms of innovation, it really drives your business faster. You're able to achieve, by offering more effective products, processes, services, and technologies and business models that really meet the new requirements and market needs of today. These innovations are enabled by business applications that are developed faster, delivered using agile methodologies, and able to scale to meet evolving demands. So you can realize faster time to value by delivering digital services more quickly. When beginning your data migration journey, it's critical for you to choose the right storage for your unstructured data. There isn't a one-size-fits-all approach. There are advantages to both file and object-based solutions. For files, some applications need to access shared files and require a file system. File storage works natively with host operating systems. There are no APIs to work into the flows or to be embedded into your code. It has strong consistency where you can easily lift and shift your legacy file-based applications to the cloud with no changes to your code or application. File storage, like what you get with Amazon EFS and Amazon FSx, is great when you have applications, users, or groups that are already using a standard network file sharing protocol to share data, and they need the flexibility and scalability of the cloud. So object storage is ideal for building modern applications from scratch and can also be used for importing existing data stores for analytics, backup, and archive. Object storage with Amazon S3 is perfect when you have the need to scale to tremendous capacities and you want to take advantage of all the economies of scale and cost that cloud storage has to offer. Data lakes build an object storage. It keeps information in its native form and includes rich metadata that allows selective extraction and use for analysis. Cloud-based data lakes can sit at the center of all kinds of data warehousing, processing, big data, and analytical engines such as Redshift, RDS, and EMR. When we are talking about data science workloads, common workloads include the genomics workloads, machine learning, financial modeling, and big data analytics. More and more organizations are refactoring traditional monolithic applications into microservices with the cloud. They are adopting a serverless operational model and a containerized approach for greater security, reliability, and scalability. In the data science world, the IT culture is shifting from autonomous teams that require faster access to tools and updated environments for greater collaboration, leveraging advanced analytics and machine learning. At a high level, you can see one of the main benefits of file storage for data science is that it easily integrates with container models. When building or migrating applications, we often need to share data across multiple compute nodes. Easy sharing of this data and insights through downstream analysis and analytics and machine learning solutions such as notebooks with Jupyter SageMaker and training jobs to train machine learning models on Amazon SageMaker is also hugely important. To realize the agility benefits offered by containers, you need to ensure that all layers of the technology stack support your development, operations, and scalability requirements. This new paradigm requires a different type of storage layer, one that is more flexible. The storage technology used to support containers should be able to support elastic scaling without any reconfiguration, enable high levels of security, and provide high availability without burdening your operations teams. Just like containers have liberated application developers to build applications free of the constraints of operating systems and infrastructure, your container storage should liberate your dev and ops teams from managing infrastructure required to support your modern applications. Talking to our customers that run analytics in their data centers with traditional NAS on-prem storage solutions, or even self-managed do-it-yourself in cloud storage solutions, they have similar frustrations with their data science environments. It's difficult when it comes to scaling, frequently running out of space and large, with these large data sets they have. It also requires procuring more servers and storage hardware, which can take months and even longer. Also, some of the frustrations are centered around the lack of agility and productivity. There's constantly forecasting needs, both on the storage and on the compute. It takes months to deploy a new model, and it's inconsistent data between analytics environments makes it very difficult. And you really are unable to collaborate or share data and insights through home directories or team folders. One of the other frustrations that a lot of our customers have when trying to manage this themselves is they spend a lot of time managing the infrastructure required to support these modern applications. And the technical debt that they have gained over the years, with maintaining this existing NAS storage and hardware, really needs to be replaced every 3 to 5 years, and that's very burdensome and it's very costly in terms of man hours as well as expense. As well as you also need to over provision your storage. With compute intensive data science environments, even in do-it-yourself environments, cloud and storage environments, you still need to over provision in order to achieve the performance that you need. Discover has made a huge investment in big data analytics and needed an environment to help their data scientists collaborate better. Many of you know Discover, with their credit cards. They have over $144 billion of card sales. They have a digital banking environment, as well as personal loans. And what they have built is, they built an open source analytics platform. It's called AR or AIR9, as a single environment for their data science teams to communicate and help enable cross-team collaboration. So some of the challenges that they faced when they were running this on-prem were frequently running out of space. It took way too many months and time to actually deploy a model, and there was a lot of uncertainty around the backups. They moved their analytics environment to AWS. It started with EC2 and EBS, but experienced challenges there with time and complexity, where their self-managed in-cloud file analytics solution was becoming a little more complex. So what was the solution? Well, they started leveraging fully managed cloud-native file systems like Amazon EFS for that collaboration storage layer. Each user on the team has a home directory, and teams and projects share a directory. They also used S3 as an archive and an historical layer for different data sets. So the results of this was that AWS enabled Discover to deliver an updated tools and environments in hours as opposed to weeks for their users. Leveraging fully managed Amazon EFS for their cloud-native file system, Discover's data science teams were able to better collaborate across tools and projects and share ideas, data sets, and insights that were never possible with on-prem. They have really seen a huge digital transformation, improving time to insights by 90%, improving customer experience, and from day-to-day customer experience, with a better mobile app, internal processes, and more adaptable fraud protection and detection capabilities with quicker model iteration and more AI and ML technologies. So one of the benefits of a fully managed file storage solution is, just like with Discover, it's easy to share data between two teams and easy to share data between tools. At AWS, we assert that high availability and protection of your data is table stakes, and it's essential to your infrastructure. How AWS defines a region is often different from how other providers define them. And with AWS, that definition is consistent across our 22 regions and 69 availability zones and counting. AWS defines a region as at least 3 geographically separated AZs or availability zones, with each AZ often consisting of multiple data centers. In fact, often what others call a region is simply an AWS availability zone. When we think about file system services, we think about really addressing 2 basic workload types: general purpose or business workloads, such as web serving, CRM, ERP applications, as well as more demanding workloads such as analytics, messaging, and various forms of content production. Compute-intensive workloads, requiring hundreds of gigabytes of throughput per second of throughput, sub-millisecond latencies, and millions of IOPS per file system include, which really is included in some of these media and entertainment, oil and gas, and even EDA type workloads. Love to take advantage of managed file systems in the cloud. Our first native file system launched in 2016. It was Amazon EFS. It is designed to provide a cloud scale file system for vast majority of Linux-based applications. Today EFS serves hundreds of thousands of customers in all 22 AWS regions. At reInvent 2018, we launched our FSX family of fully managed third-party file systems, including Amazon FSX for Windows File Server and Amazon FSX for Lustre. The Amazon FSX for Lustre is for HPC or compute-intensive workloads. Amazon FSX for Windows File Server is designed to serve all Windows workloads requiring, SMB file systems and file shares. While FSX is really designed to serve, fast processing workloads that's integrated with Amazon S3. For the remainder of this tech talk, we'll dive deeper into Amazon EFS, and I'll walk you through some of the key benefits around why customers are choosing EFS for their data science file system. EFS is our first fully managed file system, which we launched in 2016, and was designed to provide a cloud-scale file system for the vast majority of Linux-based applications. Data can be stored on a single EFS file system, giving data science users a shared workspace for code and data, which can easily be mounted on each user's data science environment. EFS uses AWS v4 for Unix and Linux operating systems, and which is a industry standard file storage protocol. When customers have a need to perform compute operations and they have their compute resources access a common data set such as a POSIX compliant file system, they really turn to NFS. Some of the other benefits of EFS is its elasticity and scalability. EFS is elastic, scaling up and down as you add and remove files, giving you the storage you need when you need it. The performance scales as your capacity grows, which, by the way, can scale up to petabytes in a single file system. EFS also gives you high performance. It supports two different performance modes, both general purpose and max I/O. You can configure your file system to best suit your needs. And with EFS, it also has two throughput modes. The default burst throughput mode is ideal for those spiky workloads that need high performance only for a short period of time, but then sort of a baseline performance for the remainder of the time. For other types of workloads, we'll need a consistent throughput. We have a second throughput mode called provision throughput mode. This is for workloads that really need a higher dedicated throughput than what is offered with the bursting throughput mode. And to put your mind at ease, though, there's a lot of super demanding workloads that are using EFS today, where some of these are able to achieve, tens of gigabytes per second throughput and up to 500,000 IOPS. EFS is also highly available and highly durable. EFS is really designed for high durability and availability. All the files and directories are redundantly stored within and across multiple availability zones in a region to prevent data loss from any single component failure. It's also secure and compliant. With EFS, you can securely access your file systems and your files using existing security infrastructures like control access with POSIX permissions, VPC security groups, and identity access management. You can also encrypt your data at rest and in transit. EFS also meets many of the eligibility and compliance requirements that you may need. We also have two different storage classes for EFS. Last February, we launched a new infrequently accessed storage class with lifecycle management to help you better optimize your EFS storage costs for files that you don't access every day. EFS Ia, or infrequent access, is designed for files not accessed every day. You'll be able to start using EFS Ia by simply creating a new file system, enabling a lifecycle management, and once your lifecycle management is enabled, EFS will automatically move files not accessed based on your policy from the standard storage class to the infrequent access storage class. This can reduce your cost up to 92%. It's also highly integrated with other AWS services for building your modern applications. Amazon EFS has really evolved to meet the changing application architectures that are out there. We have native integration with compute and machine learning models now. EFS is widely used where applications that output data to an analytics platform need to write to an NFS file system. First, when customers have the need to perform compute operations, they have their compute resources access a common data set that is POSIX compliant and accessible to Linux users who need to transform data in preparation for this analytics job. This includes data sources such as lab equipment, business applications, and machine logs. Easily sharing this type of data and insights through collaborating enables downstream analysis with analytics and machine learning solutions such as Amazon SageMaker, which I'll demo shortly. For data services, security of your data at rest and in transits are really non-negotiable. we provide encryption at rest and in transit for all your file system services. As you modernize your application architectures, we are evolving our file system services. EFS recently launched native cloud authorization support through IAM, or Identity and Access Management. This gives you the ability to leverage AWS's native authorization service for granting permissions, such as read-only, root squash, and encryption enforcement. EFS access points are also there, and we launched them recently, to enforce the use of an operating system user and group, optionally restricting access to a directory in a file system. These access points allow you to easily manage application access to NFS environments, specifying a POSIX user and group to use when you're accessing a file system and restricting access to a directory within a file system. Now, some of the use cases for these types of functionalities is really in container-based environments where developers deploy and develop their own containers. Data science applications that require read-only access to production data, and really when they have the need of sharing specific directories in the file system with some other AWS account. Using EFS Ia is super easy. It doesn't require any changes to existing applications, and EFS provides a single file system namespace that transparently serves files from both storage classes, both standard and EFS Ia. Amazon EFS Ia is a storage class that can save customers up to 92% compared to the EFS standard storage class. Customers can use EFS Ia to cost-effectively store larger amounts of data in their file system and expand their use of EFS to an ever wider set of applications. To get data into EFS Ia, you enable a lifecycle management policy, and it basically will move your infrequently accessed data over to the new EFS Ia storage class. So let's talk a little bit now about how EFS Ia works at a high level. So first, you create a file system. An EFS file system transparently serves data from both storage classes, providing a common file system namespace. So you don't have to worry about which of your files are in EFS standard or which of them are in EFS Ia. Next, you enable EFS lifecycle management for your file system. With the EFS lifecycle management, it will files that are not accessed for a lifecycle period, either 7, 14, 30, 60, or even 90 days, will be automatically moved to a different storage class, and that's the infrequent access storage class. So when having both of these capabilities under a single namespace, both EFS Ia and EFS standard, you're really eliminating the need to manually manage the data and the movement of your data to optimize cost. Migrating to EFS is also fast and easy with a service that we call Data Sync. You can copy the data in parallel over a VPN or a direct connect from an on-prem NAS array or even a self-managed NFS cluster. Accessing this on-prem NAS device over a VPN or direct connect is easy with Data Sync, as you can locally mount the file systems from your Data Sync agents, and then the Data Sync service will go ahead and transfer that data securely from your on-prem environment to your destination in the cloud. Once you've migrated all of your data, your application servers can still get access to that data that's stored in AWS over a direct connect or VPN connection. AWS Data Sync is really a data transfer service that really makes it easy for you to automate moving data between on-prem storage and some of our native storage platforms like Amazon S3, Amazon EFS, and Amazon FSx for Windows File Server. Data Sync automatically handles many of the tasks related to this data transfer process, and that really will speed up your migration over to the cloud. It is very fast, so you can transfer speeds up to 10 times faster than your typical open source tools. It's also automated, where both the management of the data transfer process and the infrastructure required for that high performance transfer is managed by AWS. The service also includes an automatic encryption and data validation. So this really minimizes your in-house development and management that's otherwise needed for a fast, reliable, and secure transfers. One-time migrations and ongoing transfers are even easy as well, where you can easily set this up and click on a one-time transfer, or you can actually automate this process by setting up a schedule. It's very flexible also in the sense that once you get your configuration set up that will suit your needs, you can also change or alter the bandwidth throttling of your transfer to minimize the impact on other applications that may be using that network connection. And you can also copy your source permissions and the metadata over to AWS. Data Sync is integrated with other AWS services, such as Amazon EFS, Amazon S3, and Amazon FSx for Windows File Server. So it makes it moving data to those storage platforms much easier. And I also mentioned this, but it is very secure and compliant. So all of your data is encrypted in transit and at rest. And for each transfer, the service performs integrity checks. These checks ensure that your data written to your destination matches the data read from your source, and it's validating consistency all the time. So the data sync really allows you to make sure that your data arrives at the destination the same way that it left the source. Celgene was one of our early adopters. And has been one of our customers for well over 5 years. They have a cloud-first strategy. This business is really focused in a biotech environment. They have a global footprint, and they are storing petabytes, even up to 20 petabytes of data. There's 3 major research and development collaborative projects at Celgene. They have a genome project. And they have some IA workloads there as well. And Celgene actually, they chose Amazon EFS to store file data for all of its R&D workloads and many of its critical applications, including some of these computational chemistry and genome compute workloads. And Amazon EFS provides a standard file system interface that really allowed them to migrate their applications to the cloud without modification to the application. So they no longer had to manage and administer the file system resources they had in-house, which really freed up the time of their IT ops to focus on their business. So with that said, let's go ahead and take a look at Amazon EFS and how easily it is to get up and running with Amazon SageMaker, our machine learning managed service. So here in my EFS console, I have a file system that I created a little earlier. It's a typical file system and has mount targets. And if we take a look at the file system policies, we'll see that we don't have any file system policies created yet. And we don't have any access points yet, but we're going to go ahead and change that here in a few minutes. If we take a look at my SageMaker environment as well, we'll see that I don't have any notebooks yet, but we're going to go ahead and create a couple of notebooks and some lifecycle configurations to allow a Juniper notebook to mount an EFS file system. So first thing we want to do is we want to just go ahead and get access to this environment. So I have an EC2 instance here, and I'm going to go ahead and connect to this instance, and I'm going to go ahead and mount that file system. So first thing we need to do is go ahead and download the EFS utils, Amazon EFS utils. Once that's downloaded, we'll be able to mount using our EFS mount helper. So this makes it very easy to mount an EFS file system, as well as making it really allowing us to leverage some of the new capabilities of using IAM and access points. So next, what we want to do is go ahead and make a mount point that we're going to mount the file system to. And now we're going to go ahead and issue our mount command. So what we're going to do here is we're going to go ahead and grab the EFS ID. So this is the file system ID of our file system. And we're going to mount that as M&T EFS. So here what we want to do is just go ahead and take a look at the file system. So we see that we have a notebook folder. We also have a train folder. So the train folder has some of our machine learning data that we're going to use for our training process. And we also have a notebook folder where all of our Juniper notebooks are going to go ahead and connect to. And right now, we can go ahead and if I went to my notebooks folder, I can go ahead and just go ahead and create a test. And we'll go ahead and see it there. So we know that we have access to it. We can read and write to this EFS file system. I'm just going to go ahead and unmount it for right now. We'll come back to this instance in a few minutes. Let's go back to the management console. And what we want to do is actually go ahead and set up and manage client access to this file system. So the first thing that we want to do is go ahead and set up an access point. So an access point can be used by applications to sort of manage how an application is going to access a file system, which directory, subdirectory within that file system, they're going to be able to have access to, and only that subdirectory. So here within this access point, I'm going to go ahead and name this a notebook. We're going to use this for our Juniper notebook instances. The user ID is going to be 1001, as well as the group ID. The path is going to be notebook, and this is where all of our notebook data is going to reside. And the owner is also going to be with 755 permissions. We're going to go ahead and create that access point. We're going to go ahead and save it. Next thing we want to do is we want to go ahead and set a policy. So right now we have a file system policy is very similar to an S3 bucket policy if you're familiar with Amazon S3. But what we can do here is we can set this policy. We can see that right now we're going to allow any user within AWS, authenticated user, to mount the file system, write the file system, as well as have root access to the file system. Again, this is only those resources that have access to my account, that have access to my VPC, that have the security group rules and the network paths that are allowed to access my EFS file system. But if I actually have other users or organizations within my organization that are maybe sharing my VPC or maybe sharing the security groups that I don't want access to my Juniper notebooks, I can go ahead and reduce and sort of only allow Juniper notebooks to have access to write access to my file system, while I allow all users to have read access to the file system. So I actually have a script already created that has all of this set up. So let me go ahead and just grab this really quick. I'm going to replace my file system policy, and we'll just walk through this really quick. So what this says is that for my file system here, basically everyone is going to be able to mount a client mount. So client mount means that they'll be able to mount the file system and read the data. They're not going to be able to write the data though. And this next statement basically says that this service role, basically this SageMaker role, will have the ability to also mount and read the data, will have the ability to write to that mount, to that EFS file system, and it will also be able to have root access to that file system. So right in here, this policy basically states that others can read my data, but only SageMaker instances that have this policy associated with it will be able to write to my file system, which is great. That's really what I want. So I'm going to go ahead and save this policy. So with my access point and my file system policy, go ahead and create a SageMaker notebook. So first thing I'm going to do is go to the SageMaker console, click on Create New Notebook Instance. Here I'll go ahead and give it a name. I'll scroll down and I want to change the configuration and add additional configuration. So here I actually want to select the, well, I'll go ahead and create a new lifecycle configuration. I'm going to go ahead and call it, we'll just call it a new one. We'll just call it IAM because we're going to be using IAM and an access point. As we scroll down here, what we can do is for each notebook when it starts, we're going to go ahead and run this script. So I actually have the script out here already where we're going to basically tell this notebook to download the EFS utils, mount the file system using this access point. So first we need to go ahead and grab that access point ID. And paste it here. And it's going to mount it as home EC2 user SageMaker EFS. And we want to go ahead and change the permissions, the modification of that directory. So that's what's going to happen when the notebook is started. When the notebook is created, we want to also just create that directory. So here that directory is going to be created. So now that we've basically created our configuration file, and everything looks good, we'll go ahead and we'll save it. So what this mount command is doing, just to let everyone know, that it is going to be using a TLS or an encrypted connection. It's going to be using the IAM role associated with this AWS resource, in my case, in a SageMaker notebook. And it's going to be using this access point. And that access point, as we created here, is basically going to be mounting it as notebook, and the user 1001 is going to have access and the permissions are going to be set at 755. So we don't have to worry about setting those permissions when we log in. And we're going to go ahead and change the permissions of that folder. So let's go ahead and save that. Just verify that lifecycle configuration is there. We'll go ahead and scroll down. We want to use that execution role. So that role, if we take a look at it, that role has a couple of things associated with it. It has SageMaker, it has full access to SageMaker, as well as this inline policy, which basically states that you can write to my file system and you can mount the file system. So with this, these policies associated with this role, and now resources that have access to that role will be able to execute the policies associated with it. In this case, accessing this EFS file system. We need to launch this instance, this notebook instance, actually in my VPC to get access to my EFS file system. So I'm going to go ahead and grab this, select the same VPC that the file system resides in, where I have my mount targets, and select a subnet and a security group that has access to my EFS file system. And that's it. Now I'm going to go ahead and create the notebook instance. So it's going to take a few minutes for that to complete. In the meantime, I'm going to go back to my EFS file system, and I want to make sure that, if my application does make any changes to my data, I want to make sure that I have a backup of the data. Amazon EFS is designed for 11.9s of durability. So I'm not backing up the data to protect the integrity of the data itself. I'm backing it up to protect against application or user issues or accidental deletes or anything like that. So what I want to do is Amazon EFS is actually integrated with AWS Backup. So we can easily go to AWS Backup and create an on-demand backup of the file system. So from the AWS Backup Console, I can go ahead and click on Create an On-Demand Backup. Here we can select the different types of resources. So here it is a DynamoDB resource. And so I can scroll down and select EFS. Here we'll be able to select the different EFS file systems within this region. So the one that we're actually going to be using is this one here. This is my SageMaker file system where all my SageMaker data is. Now we select the backup window. So we can create a backup now, or we can actually have it start in a few hours. If I wanted to kick this off later on today, I can go ahead and select one of these sort of delayed starts. But for now, I'm just going to go ahead and create the backup. We could also transition my backup to a cold storage at a later date. So, if I wanted to keep this for a long period of time, maybe years, say after, a few weeks or a few months, it could transition over to cold storage, still be accessible to me, but I can achieve or receive a much lower cost associated with storing my backup for that duration. I'm not going to worry about it because I'm not going to really keep this around too long, but I do want it to expire. I know that this data is only good for me for, say, the next week. After that, I really don't care that much about the data because it's going to be stored somewhere else. And even if I needed to rerun some of these jobs, I can also get that, always get that data from the source again if I needed to. But if something did happen to it, I would like an easy access to it. So let's go ahead and keep it around for about a week. Now I can also select the backup vault where I want to put my backup. So I'm going to go ahead and create a new vault. I'm going to call this SageMaker. So all of my SageMaker data is going to be put into my SageMaker backup vault. I could select an encryption key for that, and I can also associate some key values with my backups. Now that my backup vault is created, I can go ahead and attach additional tags to my backup job itself, where I can also change the IAM role that will be assumed when creating the backup. With that created, I'll go ahead and click on Create an On-Demand Backup, and within a few minutes, my backup will be completed. And my data will be protected, just in case when I do run some of my jobs that if I do make a mistake and alter it in some way, that I can always revert back to the previous version of that file system. Let's go back to our SageMaker console and see how our SageMaker notebook instance is going. I'll go ahead and do a quick refresh. And after a few minutes, we'll see that this SageMaker instance is in service. And all right, it's already in service. So let's go ahead and open it up. We'll go to the Jupyter Notebook instance. And from here, there's a couple of things we can do. First, we can go ahead and go to the console or go to the terminal. So here we're actually launching the terminal of this notebook instance. And we're going to see that we have my file system actually mounted. So if we do a quick mount command, we'll see that my file system is mounted. It's mounted as the home EC2 user SageMaker EFS. It's mounted as read-write, and it's also using all the standard best practices in terms of all the different mount options that we recommend because it used the EFS mount helper when it mounted that file system. We also know that it used an encrypted connection because we have the 127 IP address here, which means it's basically the loop back adapter that is used for S-tunnel to establish that a secure connection, that TLS connection. All right, so if we actually go to, let's see where we are, and then if we go to SageMaker and EFS, we'll see that we have that test file that we created earlier, but we know that we're in notebooks. You notice that we don't see the train data here because we were automatically mapped to that notebook folder within our EFS file system. That's how our access point mapped us. So what we can do is we can go ahead and test to see if we can actually write data to this folder. So we'll do a simple echo command, and we'll create a new file. So we see that we can actually write data to this folder, and that's great. You also notice that it was created as 1001. Again, that's a part of our access point configuration. If we go back down to it, we'll see that all of the it's going to be mounted as /notebook, and all the resources are going to be created as owner ID and group ID 1001 with permissions of 755. All right, next thing we want to do is we're going to go ahead and run a training job. So from the Jupyter console, we can go to our SageMaker examples. If we scroll down here, we'll see this one example here that actually has file system already integrated with the example. So we'll go ahead and copy that, create a copy of that, and that will be stored on our Juniper notebook instance. We'll go ahead and execute these sort of code snippets. We'll go ahead and run this section up here. It'll take a few seconds for that to complete. In the meantime, I'm going to go ahead and grab the file system ID and all the other information for this area. So go ahead and grab the file system ID of our file system. We'll grab the path. So the path is going to be that train path. That's where all my training data is stored. Next, we're going to be mounting this as read-only for our training instances, and we're going to be using an EFS file system. Next is my security groups. So I only have one security group that I'm going to use. I'm going to use the security group that's associated with my my file system. I'll go ahead and grab the security group ID. We also need to put in a subnet, and we'll go ahead and use the subnet ID of our US East 1A subnet. With that created, we'll go ahead and run that. Next, we're going to kick off our training model. So we'll go ahead and start that. And you'll see that, within the next few minutes, the training job is going to start. We're going to launch the EC2 instance that is created. It's going to get access to the training data that's stored on our EFS file system and run through the training model. Then within about 5 or 6 minutes, the training job will be completed. So let's hop back to our slides and we'll finish up here. So there are a couple of best practices that you should follow when you're accessing and using an EFS file system. First, we want you to test with general purpose performance mode and start with bursting throughput mode. Those are the defaults for our file systems. We also want you to use a Linux kernel 3.4 or above. And we recommend using the EFS mount helper. You saw how easy it was for me to mount an EFS file system, as well as when you use the EFS mount helper, you're able to take advantage of some of these additional functionalities like IAM integration, as well as access point integration. We also want you to access your file system using parallel methods. So we want you to use multiple threads and multiple instances. And we want you also to use large I/O, aggregate your I/O, so that you can get better throughput. Because the latency per file system operation will be aggregated over a larger amount of data, so that you can achieve higher levels of throughput. And then really the last is multiple directories. So when you're writing to your EFS file system, if you can, write to multiple directories in parallel, which could help avoid inode contention and achieve just better overall performance. So as a wrap up, here are a few resources that I would like you to look at to get more information around Amazon EFS and how you can use Amazon EFS with your data science workloads. We also have the AWS storage blog, and we have a number of reInvent sessions on this topic that we did at reInvent last year. So a lot of different slide decks you can look at, as well as videos on YouTube that you can watch. Here are a couple links too to get more information around EFS and some of the events that are coming up. With that, I'd like to say thank you very much for your time and attention today, and I'll hand it back to our moderator.